Okay, so let's unpack this today.
Yeah.
Because when I say the word carnival, what's the very first thing that pops into your head?
Oh, man. Probably cotton candy.
Yeah?
Roller coasters, maybe those rigged ring toss games, that kind of thing.
Right, exactly. We think of escapism. But for this deep dive, I want you to picture a carnival right in the heart of Shanghai.
Okay.
But instead of the smell of funnel cake and the clatter of a Ferris wheel, you walk in and you are immediately hit with this low hum of servos
Oh, wow.
and the synchronized footsteps of literally dozens of humanoid robots.
That is quite the visual. It's a pretty jarring contrast to our normal expectations, right?
Totally.
Because we associate a carnival with, like you said, escaping reality. But this event, the one outlined in our source material today, it isn't an escape at all.
No, not at all.
It's actually this highly intentional, highly orchestrated introduction to what is a rapidly approaching baseline for everyday life.
Yeah, that's exactly what stood out to me in this AI News Digest we're looking
Yeah.
at. Because this isn't just some quirky tech showcase, aimed at generating viral videos on social media.
Right. It's much bigger than that.
Much bigger. It's a massive glaring window into a state-driven shift happening in China right now.
Yeah.
It's this entire ecosystem pivoting hard toward weaving artificial intelligence directly into the physical fabric of our everyday lives.
And to really understand the mechanics of that shift, we have to kind of isolate the core terminology driving it.
Right.
The central concept they keep referencing here is embodied AI.
Embodied AI. So we're talking about essentially taking the AI out of the server rack.
Exactly.
Because up until now, the AI revolution has been, overwhelmingly digital.
Yeah, it lives on the screen.
Right. It's the large language model drafting an email for you or some algorithm optimizing a global logistics network. It's trapped. But embodied AI is pulling that intelligence out of the digital ether and giving it physical consequence.
Yes, in a three-dimensional space. And I think the jumping complexity there really cannot be overstated.
How do you mean?
Well, think about a traditional language model. It exists in this very latency-tolerant environment.
Okay.
It operates basically by predicting the next word in a sequence, right? So if it hallucinates a fact or misplaces a comma, the consequence is minimal. You just backspace.
Right. Nobody gets hurt over a bad email draft.
Exactly. But embodied AI requires a fundamentally different architecture. It relies on what are called vision language action models.
Okay. VLAs.
Right, VLAs.
So vision language action, meaning it has to process multimodal inputs all at once.
Yes.
Like it's using cameras for sight, LiDAR for depth mapping.
Tactile sensors for grip.
Right, tactile sensors. And it has to feed all of that raw data through a localized neural network and then translate it into instant kinetic output.
And it has to do all of that with zero latency.
Because the stakes are physical now.
Exactly. If a 200-pound humanoid robot miscalculates its spatial coordinates by 3 inches, it doesn't just generate a typo.
Yeah.
It crashes through a glass door or, it knocks over a patient in a hospital.
Yeah.
The machine basically has to constantly solve complex physics equations in real time just to maintain its own balance while, say, walking across an uneven floor.
Which brings us to the logistics of actually building these things. Because having a plan on paper is one thing, right? But actually building it is another.
It is a massive hurdle.
Software scales infinitely and almost instantly. You write the code, you hit compile, and literally a billion devices can download it overnight.
Right.
But hardware obeys the laws of physics. You need titanium. You need rare earth metals for these high-torque motors.
Supply chain.
Exactly. You need massive assembly lines. Mandating an AI revolution is one thing, but dragging these machines into physical reality is a logistical nightmare. Are they actually pulling this off?
Well, they are. And that's why the source material explicitly ties this carnival and this whole movement to China's latest 5-year plan.
Okay, the 5-year plan.
Yeah. This is not just a scattershot collection of independent startups, hoping for venture capital funding.
Like we might see in Silicon Valley.
Right. A 5-year plan in this context is a top-down, unified national mandate. It aligns everything: academic research, raw material supply chains, manufacturing infrastructure, government subsidies, all pointed toward a singular technological goal.
So they aren't just funding the software engineers writing the code.
No.
They are subsidizing the factory down the street that mills the physical joints for the robots.
And the testing zones where they practice walking.
Wow. So they're building the entire vertical stack at the exact same time.
Exactly. And that massive infrastructure push is what yields probably the most staggering data point in our notes today.
Yeah, I wanted to get to this. Here is where it gets really interesting, folks. According to the current ecosystem analysis in the digest, nearly 90% of global development in the field of humanoid robotics is currently localized entirely within China.
90%.
90%. I really want to pause and just think about the scale of that concentration.
It's hard to wrap your head around.
It is. Because we aren't talking about a slight competitive edge here. If 90% of the world's humanoid robotics development is happening in one localized ecosystem, they aren't just participating in the market.
No, they are completely defining the global standard.
Defining it.
And what's fascinating here is that they're basically operating inside an economic gravity well.
An economic gravity well. Break that down for me.
Well, in hardware engineering, your absolute biggest enemy is the friction of iteration.
The time it takes to go from a flawed prototype to a better one.
Precisely. So imagine you are trying to engineer a robotic hand. You need micro actuators that are strong enough to grip a heavy tool, like a hammer, but delicate enough to pick up a single egg without crushing it.
Which is incredibly hard to balance.
Extremely hard. Now, if your supply chain is globally fragmented, you design the part, you send the CAD file to a manufacturer across an ocean, and then you wait.
Yeah, you wait like 4 weeks for the prototype.
Exactly. And when it finally arrives, you test it, and you realize, oh, the thermal tolerance is slightly off.
It gets too hot.
Right. So you redesign it, you send it back, and you wait another 4 weeks. A single iteration cycle takes months.
Months of just sitting on your hands.
Right. But if you are operating inside that 90% concentration we just talked about, that friction practically vanishes.
Because everything is local.
Everything. The factory milling that custom titanium actuator is a train right away. The battery manufacturer is in the next town over. The software team writing the kinetic balance algorithms is literally working in the same building.
Oh, wow. So you can test the robotic grip on Monday, identify that thermal flaw on Tuesday.
Walk down the street to the manufacturer on Wednesday.
Right. And have a redesigned functional actuator bolted onto your robot by Friday.
Yes. The iteration speed becomes exponential.
That is wild.
So while a fragmented ecosystem is waiting on international shipping just to test their second prototype, the centralized ecosystem is already stress testing their 50th.
It drastically lowers the cost of failure.
Which is the only way you achieve true innovation in hardware. You have to fail fast and cheaply.
And that compounding advantage is exactly how you arrive at a point where you can host a public carnival showcasing these machines. The carnival is basically the visible, tangible output of that reduced friction.
Absolutely.
But, this raises a massive question for me about intent.
Okay.
With that kind of iteration speed and that level of centralization, what exactly are they optimizing for? Because if you are building this incredibly dense, fast-moving industry, you aren't doing it just to produce a dancing robot for a trade show.
Right.
Like a robot doing a backflip is an incredible feat of engineering.
Sure is.
But it doesn't shift the needle on a societal level. It's a parlor trick. So, with 90% of the development happening there, what is the actual utility they are aiming for? Are these just to show off, or are they being built for everyday life?
To find that answer, we really have to look at the specific use cases that were presented at that Shanghai event.
Okay.
Because the robots the visitors were interacting with, they were not generalized novelty items. The source material highlights humanoid robots specifically engineered and programmed to assist in healthcare settings.
Healthcare.
Yes. And others deployed explicitly for educational purposes.
Okay, see, that feels entirely counterintuitive to me at first glance.
Why is that?
Well, if I'm running a hospital, a specialized automated cart on wheels seems infinitely easier to build.
Oh, sure.
And cheaper to maintain.
Yeah.
And mathematically way less likely to fall over and break something. Why go through the monumental engineering headache of building a bipedal robot with arms and a face just to deliver medication to a patient's room?
It's a great question. And it comes down to two things: the realities of the physical environment and the psychology of the user.
Okay, let's start with the environment.
So first, consider our built world. Our entire physical world has been optimized over thousands of years for one specific form factor: the human body.
Right, the architecture of our lives.
Exactly. Stairs, door handles, the narrow space between two hospital beds, the standard height of a countertop.
Yeah, that makes sense.
If you build a box on wheels, it gets defeated by a 2-inch threshold or a flight of stairs.
A rogue cable on the floor.
Exactly. So if you want a machine to navigate our world seamlessly without requiring us to basically retrofit every building on Earth with ramps and wide doors, you have to design the machine to fit the world.
Form follows environment.
Exactly. A humanoid robot simply steps over the threshold. It turns the standard door handle.
Okay, I get that. The physical utility makes sense.
Yeah.
But you mentioned the psychology of the user, too, which is fascinating when we talk about healthcare and education specifically.
It really is, because these are high-touch, vulnerable sectors.
Yeah.
If you are in a hospital bed, you are likely stressed, you're in pain, you're seeking comfort. A rolling metal box dispensing a pill feels cold. It feels clinical and isolating.
Yeah, feels very dystopian.
Right. But humans are biologically hardwired to read faces.
Oh, interesting.
We interpret body language automatically. We seek out what's called kinematic mirroring. We fundamentally trust things that move the way we move.
Wow.
So a machine with a recognizable face, with arms that gesture naturally, that approaches a bed with a soft, calculated posture, it fundamentally alters the interaction.
It essentially hacks our empathy.
That's a good way to put it.
We project understanding onto it because it looks and moves like us, even if we know it's a machine.
Exactly. And the official strategy, as noted in the text, refers to this as a, quote, seamless blend of AI with human interaction.
A seamless blend.
The true objective in these sensitive sectors isn't just task completion. It's about enhancing efficiency without sacrificing the psychological comfort of human-like interaction.
So they aren't just trying to automate a warehouse supply chain.
Yeah.
They are attempting to insert AI into the most intimate, care-focused pillars of society.
Yes. And the source material uses an analogy for this integration that I think perfectly captures the scale of the ambition here.
So the smartphone comparison?
Yes. The stated vision is for these humanoid robots to eventually become, quote, as commonplace as smartphones are today.
It is such a wild comparison, but it makes so much sense when you trace the historical trajectory of the smartphone.
Walk me through it.
Well, think about the phone in your pocket right now.
Yeah.
There was a time, historically not very long ago, when a mobile phone was a luxury item.
Right. The car phones.
Yeah, it was a heavy, clunky brick tied to a car battery. And it was basically used exclusively by Wall Street executives.
Yep.
And then it became a flip phone, which was common, sure, but it was still just a single-purpose tool for making a call or sending a text.
Right.
But then the hardware and the software merged into the modern smartphone, and the societal shift was basically instantaneous.
It really was.
It went from a novelty to an invisible necessity almost overnight. It became this ambient extension of our nervous system. You don't marvel at the engineering of your smartphone when you pull it out to check the weather, right?
No, not at all.
Or when you navigate a new city. You don't even realize you are using it. It is completely, utterly mundane.
And that transition from spectacle to invisible necessity is the exact trajectory this 5-year plan is targeting for embodied AI.
It's kind of hard to picture, though.
Well, think about it like this. Today, if you walk into a hospital room and see a bipedal robot standing next to the bed, your jaw drops.
Oh, absolutely. I'm pulling out my smartphone to record it.
Right, because it's a spectacle. It belongs at a carnival.
Wow.
But the objective is a future where you walk into that exact same room, you see a humanoid robot adjusting an IV drip, and you don't even break your stride.
Wow.
You simply ask it for an update on the patient's vitals, the exact same way you casually ask a smart speaker to set a timer in your kitchen today.
So you stop seeing it as a marvel of engineering, and you start seeing it as just another piece of the furniture.
Exactly. The absolute normalization of synthetic physical presence.
That is wild.
And this brings us full circle back to why that 90% development concentration is so critical.
How so?
Because to reach that level of absolute normalization, where a humanoid robot is as ubiquitous as a smartphone, you need to achieve mass production on an unprecedented scale.
Right. You can't have them costing $1 million each.
Exactly. You need flawless reliability, and you need the manufacturing cost to absolutely plummet.
And you can only do that if you own the whole supply chain.
Yes. By centralizing the entire ecosystem, the raw materials, the software, the manufacturing, the government policy, they are deliberately compressing the timeline required to turn that science fiction into a commercial reality.
So when we strip it all down, This isn't a story about a carnival at all.
Not really.
It's a story about a highly calculated preview of a new baseline. What the source material is showing us is that China is executing this massive state-mandated push to give artificial intelligence a physical body.
Yes.
They are leveraging that economic gravity well to iterate faster than anyone else on the planet, building machines designed to seamlessly integrate into our homes, our hospitals, and our schools.
The Carnival in Shanghai is simply the proving ground.
The beta test.
Right. It is a controlled environment designed to test how humans react to these machines in a public space. It serves as a snapshot of this awkward transition period between the technological spectacle of today and the mundane reality of tomorrow.
It definitely forces you to look at the devices we currently rely on through a completely different lens.
How do you mean?
Well, if the end game here is to make humanoid robots as ubiquitous as our smartphones, teaching our children, providing our healthcare, moving independently through our physical spaces, it fundamentally changes our relationship with technology.
It certainly does.
Because right now, your smartphone is just a pane of glass in your pocket. It is a tool. But if we eventually rely on these physical machines with the exact same intensity that we rely on our phones today, how does our brain process that relationship?
That's the real question.
Right. When the technology providing our daily care has a face and arms and physical weight in the world, and it moves and speaks just like we do, how long before we stop treating it as an appliance and start treating it as a companion?